Okay, so they can't always be that simple. So I'm going to go through a couple of stoichiometry calculations that are a little bit more complicated. We don't typically just work with moles. We work with grams. We work with liters. We work with things that we can measure in the lab. So we might have a question like this one. How many liters of SO2 will be produced if 24.6 grams of FeS2 react? Okay, so now we're looking for liters. We are starting in grams, which is a mass. And so this is a much more complicated problem, many more steps, okay? So if we are starting with a mass, we're starting in mass of A, and I'm asking you to find a volume of something that's a different substance. So I'm trying to go to volume. Again, we're assuming STP. We haven't gotten to these knotted STP corners quite yet, okay? So we're starting in mass, and we're trying to go to volume of something else at STP. So I'm going to need a mole mass, I'm going to need a mole ratio, and I'm going to need molar volume in order to do this calculation. So the mole ratio piece, that's the stoichiometry piece. That will be the center part of our calculation. But on either side, we have other conversions to get done first. Okay, I'm going to try to squeeze this in so you can see it. I'm sorry if I write too small. I'm going to do my best. Okay, always, always, always start with what you're given in the problem. So 26.4 grams of FeS2. Okay, 26.4 grams. If you are starting in mass and you're doing a conversion, the first step, no matter where we're trying to go, is going to be the molar mass of the substance. So to save us a little bit of time, I put the molar masses of the substances up here. And for FeS2, the molar mass is 120.0. As a reminder, the way we get our molar mass, you look at the front of your periodic table, find the mass of iron, you add 2 times the mass of sulfur to that iron, and you're going to get the total, 120.0 grams per mole. So where do I want to put my grams? Where do I want to put my mole? So 120.0 grams equals 1 mole of FeS2. Grams need to be on the bottom in order to cancel. So 120.0 grams of FeS2 for every 1 mole of FeS2. So my grams of FeS2 cancel out. Now I'm to the moles. When you're in moles, to get to moles of something else, mole ratio. I care about FeS2 and SO2 in this reaction, so 4 moles of FeS2 for every 8 moles of SO2 in the reaction. You can reduce that, but remember, every time you do a little math problem in your head, you're opening yourself up for a potential for error, so just be careful with that. I'm just going to use it as written, so 4 moles FeS2. I put that on the bottom because here is moles of FeS2. I want that to cancel. 8 moles of SO2 on the top. So moles of FeS2 cancel. Now I'm in moles of SO2. I am trying to find liters of SO2. Okay? So far I have gone from mass to moles, and then I use the mole ratio to get to moles of B, moles of SO2. But I'm trying to find liters of SO2. So I'm going to go down, and I need molar volume to do that. So if you remember from chapter 10, 1 mole of a gas at STP has a volume of 22.4 liters. Okay. So where do I want to put my 1 mole? Well, I want moles to cancel. So 1 mole of SO2 is 22.4 liters of SO2. So moles cancel out. Everything cancels except for liters of SO2. So that's what I'm looking for. And also, if we look at this to look for sig figs, okay, 26.4 has 3 sig figs, divided by 120.0 times 8 divided by 4, and then times 22.4, okay, oh, I did something wrong there, but we got 3 sig figs, 4 sig figs, infinite sig figs, 3 sig figs, so my answer is going to have 3 sig figs. All right, that's better. So 3 sig figs. To round my answer to 3 sig figs, I get 9.86 liters of SO2. Okay. That one works because we have a gas, so we can go to liters. Here, I'm looking at grams and grams. I could have used liters for the oxygen, but I just chose to do a grams problem. But grams to grams, same number of steps. We're going to work from mass of A all the way to mass of B, okay? And again, it doesn't matter what side of the equation these masses are on, okay? I have our A as a reactant and our B as a product, but I could have done it the other way around. I could have given you grams of the product and said, how many grams of oxygen would you need to make this? Okay, like how many pickles or how many pieces of bread do you need to make 4 sandwiches? Well, you're going to have a product to reactant instead of reactant to product. It's fine. They both work, okay? So 14.7 grams of oxygen is my starting point. Anytime you're starting with mass, your first step is molar mass. So 1 mole of oxygen, and it's diatomic, so we had to double its mass. We get 32.0 grams of oxygen. Grams cancel out. My next step after I'm in moles is the mole ratio. Well, what do I care about here? Oxygen and iron oxide. My mole ratio, 11 moles of oxygen for every 2 moles of iron oxide. And we want them arranged so that we get some cancellation. Moles of oxygen is here, so I want moles of oxygen to be on the bottom to cancel out. So 11 moles of oxygen for every 2 moles of Fe2O3. Okay. And then my last step, to get to grams of Fe2O3, I need its molar mass. So 1 mole of Fe2O3, moles cancel, is 159.6 grams of Fe2O3. Okay, again, I added up 2 irons and 3 oxygens to get that number. Okay, punching this all into the calculator, 14.7 divided by 32.0 times 2 divided by 11 times 159.6. And you're going to end up with a number that you have to round then to 3 sig figs. So 13.3 grams of iron oxide is the answer to that one. Okay. All right, next video is going to be limiting reactants, and then we'll do percent yield.